Semiconductors make the backbone of a modern society. Most of these micro devices make use of silicon and silica layers, providing a world with seamless precision and certainty by their applications. But ironically enough, these silica layers are fundamentally brittle in nature, and their strength is purely passive, meaning it is dictated by the random microscopic defects that may arise during the manufacturing process, as a result of which there occurs a huge scatter in their strength values. Because we may not know when or how these structures may snap, engineers have to compensate with restrictive safety margins while designing, which severely limits how small and energy efficient these devices could become. This is the wall I wish to break. I propose a technique to actively control how a structure breaks at the nanoscale, and we achieve this by utilizing electron beam to implant crystalline silicon nanodots inside the silica substrates. Now, crystalline silicon, having a higher fracture toughness than the amorphous silica, behaves as a strategic obstacle that forces any microscopic cracks to stop and detour. As a result of this, the strength of the structure potentially increases by 3 times, and the strength variability reduces by a factor of 10. Most importantly, this strengthening technique is independent of the fabrication history, meaning that we can strengthen our devices by simply irradiating them with electron beam without making any major modifications at the current existing fabrication lines. Well, we are going further. Packing these nanodots together paves pathway for a major technological breakthrough. That is a highly sensitive fail-safe strain sensor. Yes. So by the virtue of quantum tunneling effect, there occurs electricity between adjacent nanodots. Now, under an extreme mechanical stress situation, these nanodots would tend to drift apart, ultimately cutting off this tunneling current. And the structure behaves essentially as a nanomechanical fuse, which electrically insulates itself before any mechanical destruction occurs. Essentially, ensuring the technology that keeps us safe is truly fail-safe. Thank you.
Thank you, Abbhiraj. Any questions from the jury?